Assalamualaikum and a very good morning to our lecturer, Sir Azli and Sir Safi. Today, we are going to present about Mechanical Workshop Practice 2 in Foundry. First of all, here is the list name, which is Javier Cruz Jerowin, Muhammad Airil bin Mansor, Amirah Mizaraf Hana, and Livandro Ana Gilbert. So, here is the list of table content, which is Introduction, through inspection checklist for Foundry Workshop, potential hazards in Foundry Workshop, steps in a Foundry Workshop for metal casting of our projects, and the last one is defect of our workpiece and how to prevent defects.
Introduction of the Foundry Workshop. The definition of a foundry workshop is a factory on where metal casting is carried out. In a foundry, metal is melted and poured into molds to create specific shapes and components used in various industries such as automotive, construction, and machinery. Foundry works involve high temperatures, heavy equipment, and various processes that require strict safety and operational standards. Therefore, regular inspection is essential to ensure that the workshop operates efficiently and safely.
Through inspection, checklist for Foundry 1, 2, and 3, and 4. Okay, first, general housekeeping. Workshop is clean and tidy. Good lighting and ventilation. Walkway are clear. Second, safety. Fire extinguisher are available. Worker wearing PPE. And emergency exit are clear. Okay, for the third, molding section. Mold and pattern stored properly. Sand and material handled safety. Machine are working smoothly. And the last point is furnace area. Furnace is in good condition. No gas or the oil leak. And temperature control are working.
Okay, potential hazard in foundry workshop. First, heat and burns. Workers in foundry workshop are exposed to the risk of heat and burns from contact with molten metal, hot surface, and spark during pouring. Second, dust and fumes. Silica dust from sand molds and fumes from melting metals like zinc and aluminum can cause serious respiratory diseases, especially in poorly ventilated areas. The third, physical injuries. There is a high risk of physical injuries to falling objects, slips and trips, and being caught in moving machinery. The fourth, lifting and handling. Improper lifting technique with equipment failure or drop loads can lead to muscle strain and other serious injuries.
Inside the mold.
4. Melted aluminum making process. In a foundry workshop, a melted aluminum machine, typically a furnace, is used to heat the aluminum to a liquid state for casting or shaping. These furnaces come in various type and size, including electrical induction furnace, combustion based furnace, and tilt type furnace. 5. Melted the metal. Metal like the aluminum, iron, and bronze is melted in a furnace. For an example, induction cupola or crucible. And second, temperature is closely controlled for quality.
The step 6 is pouring. The molten metal is carefully poured into the mold cavity, and safety process rigorous and follow up strictly due to the high temperatures. Step 7 is cooling and solidification. The molten metal is poured into the mold hole through a well-designed runner system is crucial for efficient and defect-free molding. Other than that, proper gating ensures even flow and reduces turbulence.
The eighth step is shakeout. Once solidified, the mold is broken open to remove the casting, sand from the mold and shaken off and often recycled. The ninth step is cutting and cleaning. The casting is cleaned to remove sand, scale and excess metal. The 10th step is inspection and finishing. The casting is inspected for defects, inclusions, cold shut, and misruns. And then the final finishing step is machining, heat, treatment, and painting are applied if needed.
Next, we move to the next part, which is defect of our workpiece in Foundry. Inclusions. So, the first one, we cut inclusions defect. Cost of inclusions defect is improper cleaning of the mold cavity, presence of slag or dross in molten metal, inadequate fluxing or filtration, poor gating system design that allowed turbulence, and the last one is use of contaminated or recycled metal. How to prevent inclusions? First thing first is ensure clean molds and tools before pouring. Next, use fluxes to remove slag from molten metal. Third, install ceramic filters in the gating system. Fourth, pour metal smoothly to reduce turbulence. And lastly, use high quality, clean metal charged materials. So, there is a example picture of slag inclusion.
Finally, defect on our workpiece. On our workpiece, we got a hot or cold crack caused by a crack defect. For an example, the hot crack occurred due to high thermal stress during solidification when metal is still soft. And for the cold crack, it's happened after solidification, often due to shearing edge or residual stress. The poor design with the sharp corner or option section changes, rapid cooling or uneven cooling rates, and lastly, high material hardness or brittleness. Okay, for the second defect, okay, how to prevent crack? We have to use the proper casting design with smooth transition. Second, control the cooling rate to avoid thermal gradients. And third, preheat mold if necessary to reduce cooling shock. Fourth, ensure a proper alloy composition and grain structure. And fifth, avoid excessive use of hardness or improper heat treatment. Thank you.
In conclusion, the foundry process plays a vital role in the manufacturing industries. By enabling the production of complex metal components with precision and efficiency, it involves key stages such as pattern making, molding, melting, pouring, cooling, and finishing. By understanding the different casting methods, materials, and safety precautions, Foundry can ensure high-quality outputs while maintaining worker safety and environmental responsibility.